I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on haloalkanes and reactions of the haloalkanes. So before us, a typical chemistry A-level questions on halogenoalkanes and reactions of the halogenoalkanes. Now, the presence of a halogen in an organic compound may be detected by warming the organic compound with aqueous silver nitrate. Which compound will be the quickest to produce a precipitate? So this reactions of the halogenoalkane has to do with the strength of the carbon halogen bond, the strength of the carbon halogen bond, and the strength of the carbon halogen bond decreases as you go down the group. So what happens? Carbon fluorine bond have the strongest. Then we'll have what? Carbon chlorine. Then we'll have what? Carbon bromine. And we'll have carbon what? Carbon iodine. Carbon iodine is the weakest. The weakest. The weakest. So the rate of reaction depends on the strength of the carbon halogen bond. So carbon iodine bond is the weakest, followed by what? Carbon bromine. Carbon fluorine is the strongest, and carbon chlorine, they are stronger. So what happens is that what? It will take time for the bond to break and for the reaction to take place. So which compound will be the quickest to produce the precipitate? So I have to erase this so that I will have enough space. So which compound will be the quickest to produce the precipitate? So when the halogen breaks from the carbon halogen bond, it will react with silver to form a precipitate of either silver chloride, silver bromide, or silver iodide in form of what? Precipitate. So we're going to look at the options. The options that contain what? The carbon iodine bond will be the quickest to produce a precipitate. So A is not the answer. A is wrong because A contains carbon chlorine bond, which is very, very strong. B is also wrong because B contains carbon chlorine and carbon fluorine bond, which are very, very strong. So C, I think C should be the correct answer because C contains the carbon iodine bond, which is the weakest and can easily break. D is wrong because D contains carbon chlorine, carbon bromine, and carbon fluorine bond. So the correct answer to this question is what? C. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me and I'm there for you. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on halogenoalkanes and reactions of the halogenoalkanes, otherwise known as what? Haloalkanes and reactions of haloalkanes. Before us, a typical chemistry A-level question on halogenoalkanes. Now, a student converts one iodopropane C3H7I into what? Butanoic acid C3H7CO2H, a two-stage chemical synthesis. In the first of the two stages, which reagent is reacted with one iodopropane? Now, what happened is that what in nucleophilic substitution of halogenoalkanes, when halogenoalkanes react with ethanolic solution of potassium cyanide, you get a nitride. Then when the nitride undergo hydrolysis, they will get a carboxylic acid. So from what we have here, the first one is what? Iodopropane, which is a halogenoalkane, reacts with ethanolic, so it's converted into butanoic acid. So first of all, the iodopropane, which is a halogenoalkane, have to react with what? Ethanolic solution of potassium cyanide to form a nitride. Then the nitride will form what? Butanoic acid, which is C3H7COOH, because the nitride will contain an extra carbon atom. So in the first of the two stages, which reagent is reacted with one iodopropane? A is wrong because if A reacts with iodopropane to react with A is aqueous sodium hydroxide, so it form an alcohol. So A is not the answer. If you look at B, ethanolic solution of ammonia, if you react to iodopropane, you are going to get what? An amine. And an amine cannot be hydrolyzed to get the carboxylic acid. So B is wrong. Then if you look at C, C is ethanolic potassium cyanide. So C is the correct answer because if ethanolic potassium cyanide react with a halogenoalkane, it will give you what? It will give you a nitride. Then when the nitride undergo hydrolysis, it will give you a carboxylic acid. So C is the correct answer to this question. D is wrong because ethanolic solution of sodium hydroxide react with the halogenoalkane to form what? An alkane. So C is the correct answer. So it's as simple as what? ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on haloalkanes and reactions of haloalkanes, otherwise known as halogenoalkanes, and reactions of the halogenoalkanes. Before us is a typical chemistry A-level question on haloalkanes and reactions of the haloalkanes. Now, which statement is correct? So we're going to look at the options and we're going to bring out the correct statement, and it has to do with reactions of the halogenoalkane. Option A, bromoethane reacts with aqueous sodium hydroxide to form ethane as a major product. Bromoethane is a halogenoalkane, and when halogenoalkane reacts with aqueous sodium hydroxide, they will form an alcohol, so not an alkane. So A is out of the answer. A is wrong. Now let's go to B. Option B. 1-chlorobutane reacts more rapidly than 1-bromobutane with aqueous sodium hydroxide at the same temperature. Now, reactions of the halogenoalkane has to do with the strength of the carbon halogen bond, the carbon chlorine and the carbon bromine, the carbon iodine bond, which is the carbon halogen bond, where X represents the halogen. If you look at the strength of the carbon chlorine bond is stronger than the strength of the carbon bromine bond. So what happened is that 1-bromobutane will react rapidly than 1-chlorobutane. So option B is wrong, because 1-chlorobutane will not react more rapidly than 1-bromobutane, because 1-chlorobutane contains carbon chlorine bond, which is stronger than 1-bromobutane. So the answer to the B is the wrong answer. B is not the option. Now let's look at option C. Hydrolysis of C2H5-3CB occurs mostly by SN2 mechanism. If you look at this halogenoalkane, this is a tertiary halogenoalkane. You can see that the carbon atom bonded to a halogen is bonded to 3 alkyl groups and no hydrogen atoms. It bonded to 3 alkyl groups and no hydrogen atoms. So tertiary halogenoalkanes undergo what? SN1 mechanism. When we talk about SN1, means substitution nucleophilic unimolecular, whereby with the S stands for substitution, N stands for nucleophilic, 1 stands for unimolecular, which is an indication that the rate of reaction depends on the concentration of the halogenoalkane and not on the nucleophile. So hydrolysis of tertiary halogenoalkane occur mostly by SN1 mechanism and not by SN2 mechanism. So C is wrong. C is not the option. So the correct option is D, because the CH3 CH2 ion is less stable than the CH3-3C ion. So this is a tertiary carbocation. A carbocation is a positively charged carbon atom. This is a tertiary carbocation, while this is a primary carbocation. And tertiary carbocation are more stable than what? Primary carbocation. So the primary carbocation is less stable than the tertiary carbocation. So D is the correct answer to this question. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me if you encounter any difficulty or any challenge. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on haloalkanes and reactions of the haloalkanes, otherwise known as halogenoalkanes, and reactions of the halogenoalkanes. So before us is a typical chemistry A-level question on halogenoalkanes and reactions of the halogenoalkanes. Butanoic acid can be produced from 1-bromopropane in 2 steps using reagent V and W as shown. 1-bromopropane react with reagent V to give a compound Q. Compound Q react with reagent W to give a butanoic acid. What could be reagents V and W? So we have to identify reagent V and reagent W. Now from our knowledge of what halogenoalkanes, from what we treated in halogenoalkanes, when it has to do with reactions of the halogenoalkanes, the major reactions of the halogenoalkanes, which is known as what? Nucleophilic substitution. Now, when halogenoalkanes undergo nucleophilic substitution, they will either give you a nitrile, an amine, or an alcohol. So what happens is that from what we have here, we have 1-bromopropane, which is halogenoalkane, react with reagent V to give you a compound Q, which will now react to give you butanoic acid. So what happened? That means reagent V should be what? When 1-bromopropane reacts with ethanolic solution of potassium cyanide. So reagent V to give you a nitrile. Then when you hydrolyze a nitrile, you get carboxylic acid. So reagent V should be potassium cyanide. Reagent V should be potassium cyanide in ethanol. Ethanolic solution of potassium cyanide on 1-bromopropane. So 1-bromopropane, which is a halogenoalkane, reacts with ethanolic solution of potassium cyanide to give you what? To give you a nitrile, which is butane nitrile, which will now be CH3, CH2, then Cn. So you get a butane nitride. So this is compound Q. Compound Q is what? Butane nitride. Now when compound Q now undergo hydrolysis, acid hydrolysis of a nitride will give you a carboxylic acid. So if you hydrolyze what? Butane nitride, you get butanoic acid. So we are using dilute. So reagent W should be what? Dilute what? Aqueous hydrochloric acid, which is AQ. So when it undergo acid hydrolysis, you get what? A carboxylic acid, which is butanoic acid, which will now be CH3, CH2, CH2, then COOH. That means reagent V is what? Potassium cyanide in ethanol, and reagent W is what? Aqueous solution of hydrochloric acid. So the correct answer to this question is what? A. Potassium cyanide in ethanol and aqueous solution of what? Hydrochloric acid. So it's as simple as ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge, any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on haloalkanes and reactions of the haloalkanes, otherwise known as what? Halogenoalkanes and reactions of the halogenoalkanes. Before us, a typical chemistry A-level question on halogenoalkanes and reactions of the halogenoalkanes. Now, compound R can be formed from one bromopropane using a nucleophilic substitution reaction, followed by an oxidation reaction. What is the identity of compound R? Now, if you look at the reactions of the halogenoalkanes, one of the reactions of the halogenoalkanes is nucleophilic substitution. And when halogenoalkane undergoes nucleophilic substitution, they will produce an alcohol depending on the reagent, or they will produce an amine depending on the reagent, or they will produce a nitride depending on the reagent. Now, what happens is that what? One bromopropane is a halogenoalkane. So when it reacts with what? Aqueous solution of sodium hydroxide, this is one bromopropane, which is CH3, CH2, CH2Br. When it reacts with aqueous solution of sodium hydroxide through nucleophilic substitution, you get an alcohol, which is CH3, CH2, CH2OH, which is propanol plus what? Sodium bromide. Now, when to produce an alcohol. Now, when the alcohol undergoes oxidation of an alcohol, this is a primary alcohol. Oxidation of a primary alcohol using acidified potassium dichromate 6. Using acidified potassium dichromate 6. If it undergoes oxidation of a primary alcohol is going to give you what? A carboxylic acid. So you are going to get propanoic acid, which is CH3, CH2, then COOH. So oxidation of an alcohol using acidified potassium dichromate 6, you get what? A carboxylic acid. So the alcohol is propanol. So when it undergoes oxidation, it will produce what? Propanoic acid. So the correct answer to this question is what? A. The answer is propanoic acid. So the identity of R is what? Propanoic acid, which is what? A as the correct answer. So it's as simple as ABC. Attempt as many questions as possible. Feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.